Whenever measurements are made, there always is some amount of uncertainty in the obtained result. This uncertainty is known as an error. When talking about errors in an instrument, we need to define two terms, accuracy and precision. Accuracy is a measure of how close the measured value is to the true value. Precision is a measure of the resolution to which the quantity is measured. For example, let us attempt to measure the length of an object. Its true length is 6.589 meters. Measuring the length using one instrument gives us 6.4 meters. A second instrument gives us the reading 6.38 meters. Obviously, the first instrument is closer to the actual value and hence is more accurate than the second instrument. However, we see that the first instrument has a resolution of 0.1 meters, while the second instrument has a resolution of 0.01 meters. Thus, the second instrument is more precise than the first one is. Errors can be classified broadly into two categories: systematic errors and random errors. Systematic errors are errors which tend to be in one direction only, either the positive or the negative. Systematic errors may occur as a result of imperfect calibration of the measuring instrument. For example, improper calibration of a thermometer may result in it showing the temperature to be greater than 100 degrees at the boiling point of water. Such errors are called instrumental errors. Systematic errors may also occur due to incorrect experimental techniques. For example, placing a thermometer in your armpit always gives a lower value of temperature than the actual temperature of the body. Systematic errors may also occur due to incorrect handling of the instrument by the user. For example, measuring temperature under an air conditioner will never give us the correct value of temperature. Random errors, on the other hand, are true to their name, random in nature. They may occur due to a fluctuation in experimental conditions and hence are difficult to predict. When random errors occur, multiple readings of the same observation may give us different values. Least count error is another kind of error which depends on the resolution of the instrument. Least count of an instrument is the smallest value that can be measured by that instrument. Least count error occurs because of differences in precision of different instruments and may be reduced by using instruments which are more precise in nature. Absolute error, relative error, and percentage error. The magnitude of the difference between the true value of the quantity and the individual measurement value is called the absolute error of the measurement. Since the true value of the quantity may not always be known, it is assumed to be the arithmetic mean of several observations of its value. The difference between the true value and the individual measurement may be positive or negative, but the absolute error is always positive in nature. The arithmetic mean of all the absolute errors is taken to be the final or the mean absolute error of the physical quantity. The relative error is the ratio between the mean absolute error and the mean value of the quantity being measured. When this ratio is expressed as a percentage, then the error is known as percentage error. Combination of errors. When two quantities are added or subtracted, the absolute error in the final result is the sum of the absolute errors in the individual quantities. For example, let Z be a combination of two quantities, x and y. Z equals x plus y. Z plus or minus delta Z equals x plus or minus delta x plus y plus or minus delta y. Maximum possible error is delta Z equals delta x plus delta y. For the difference z equals x minus y, z plus or minus delta z equals x plus or minus delta x minus y plus or minus delta y equals x minus y plus or minus delta x plus or minus delta y, or plus or minus delta z equals plus or minus delta x plus or minus delta y. When two quantities are multiplied or divided, the relative error in the result is the sum of the relative errors in the multipliers. Thus, when two quantities are being multiplied, the maximum relative error is delta z by z equals delta x by x plus delta y by y. The relative error in a physical quantity raised to the power k is k times the relative error in the individual quantity. Thus, if z equals u raised to p v raised to q by w raised to r, delta z by z equals p into delta u by u plus q into delta v